Hey guys, welcome to another video of CSAT with Justin. So in this video, we'll be talking about HCF and LCM. We will look into their concepts and we'll also look into various methods in finding out HCF and LCM, and we'll be also doing some questions as well. So if you like this video, please do subscribe, share and support. So let's start with the video. So what is HCF? So HCF means highest common factor. So before looking into what HCF is, you need to know what common factors are. So let us take one example. Let us take three numbers. Let's say 20, 40 and 60. So the factors of 20 are 1, 2, 4, 5, 10 and 20, because 1 into 20 is 20. 2 into 10 is 20 and 4 into 5 is 20. So these are all the factors of 20. So similarly, when we take the case of 40, we have factors 1, 2, 4, 5, then 8, 10, 20 and 40, because 40 is 1 into 40, 2 into 20, etc. Right, now when we look into 60, we have 1, 2, 3, 4, 5, 6, then it will come 10, 12, 15, 20, 30 and 60 as factors. So if we look into these factors of 20, 40 and 60, we can see various common factors, right? So 1 is a common factor in all these cases. 2 is a common factor in all these cases. Then we have 4 as a factor in all the cases. We have 5 as a factor in all the cases. Then we have 10 as a factor in all the cases. Then we have 20 as a factor in all the cases as well. So we have here common factors are 1, 2, 4, 5, 10 and 20. So among these, the highest common factor is 20. So this is the concept of HCF, or highest common factor. So if you are asked what is HCF, it is the highest among the common factors of various numbers. So now let us look into various methods to find HCF. We have three methods. So I am talking about the first method, that is the long division method. So this method, we don't usually use this method because it is actually difficult to find HCF using this method. We'll be mostly using prime factorization method. So anyway, you just need to understand how this method works. Okay, so let us take an example. We need to find out the HCF of 48, 72 and 108. So in order to find the HCF, you need to take first two numbers. Let's say we are taking 48 and 72. Among those two numbers, 72 is the highest number. So take 72 as the dividend and 48 as the divisor. So do the division. So 1 into 48 is 48. You will get 24 as the remainder. Now in the second step, you need to take this 48 as the dividend. Okay, so here you need to write 48 and you need to divide 48 by 24. So 2 into 24 is 48. You will get 0 as remainder. So once you get 0 as a remainder, you need to take the third number. So here third number is 108. Now you need to divide 108 with this number. That is the latest divisor in the previous step, that is 24. So you need to divide 108 with 24. Now if you do 4 into 24 is 96. You will get 12 as the remainder. Now you need to take this divisor as the dividend in this step. Okay, so that is you need to take 24 here. Then 2 into 12 is 24. You will get 0 as the remainder. So once you get 0 as remainder, you can stop here. So the final divisor will be the HCF. So here HCF of 48, 72 and 108 will be 12. So this is the first method, that is the long division method to find out the HCF. So let's now look into the second method to find HCF, which is the repetitive subtraction method. As I already told you, we'll be using mostly prime factorization method to find out the HCF in different questions, but sometimes repetitive subtraction will be much more easier than the prime factorization method. Okay, so you need to understand this method very well as well. Okay, so I'll be doing a question in the later part of this video to help you understand where repetitive subtraction will be easier than the prime factorization method. So now let's take an example. Let's take the same example, that is let's say we need to find out the HCF of 48, 72 and 108. So here you need to subtract two numbers first. That means HCF of 48, 72 and 108 is same as HCF of 72 minus 48, 108 minus 72, 108 minus 48. That means we are taking the differences between the different pairs. So here one pair is 48 and 72, one pair is 72 and 108, and another pair is 108 and 48. So you need to take the differences. So especially when you are asked to find out the HCF of bigger numbers, if both the three numbers given to you are bigger numbers, then repetitive subtraction will be much more easier. Okay, so here this is HCF of, this is same as HCF of 24, that is 72 minus 48 is 24, 108 minus 72 is 36, and 108 minus 48 is 60. Now you can repeat this step, that is why it is called as repetitive subtraction. Okay, so repeat this step. That means this is equal to HCF of, take two pairs, that is 36 minus 24, then you have 60 minus 36, then you have 60 minus 24. So we'll get this is equal to HCF of 12, then here you will get 24, here you will get 36. Now again repeat this step, you will get HCF of 24 minus 12 is 12, 36 minus 24 is again 12, 36 minus 12 is 24. So here in the next step, again if you repeat, you will get 12 minus 12 as 0. If you are getting 0, just write the same number itself, don't write 0. Okay, so 12 minus 12 is 0, so we'll write the same number 12, and 24 minus 12 is again 12, and 24 minus this 12 is also 12. So see, here you got all the numbers same. That means HCF of 48, 72 and 108 is equal to 12. So this is the second method by which you will be finding out the HCF. So now let us look into our third method, which is the prime factorization method, and which is the most commonly used method. So here you need to do the prime factorization of 48, 72 and 108. So in all these three numbers, take out or find out whichever prime numbers are coming common. Okay, so in all these three numbers, 2 is a common prime factor, right? So you'll take 2 here, then 24, 48 divided by 2 is 24, you'll get 36 here, and you will get 54 here. Okay, then again 2 is a common factor, so take 2, that means 12, 18 and 27. So in 12, 18 and 27, 3 is a common factor, right? So take 3, that means 4, then you have 6 here, then you have 9 here. So in 4, 6 and 9 there are no common factors, right? So you can stop the calculation here. Then the HCF will be equal to, multiply all the numbers that you got here. That means 2 into 2 into 3. 2 into 2 is 6, 2 into 2 is 4, 4 into 3 is 12. So you got HCF as 12. So in all our methods, that is in the long division method, in the repetitive subtraction method, and in the prime factorization method, we got HCF as 12. So whichever method you use, you will get HCF as the same number. So whichever method is you find easier, you can use that method. But mostly we'll be using prime factorization method, which is I think I'll suggest you to use this prime factorization method, except in some exceptional cases where you will be using repetitive subtraction method. Now let's see what LCM is. So LCM is lowest common multiple. So before looking into what LCM is, you need to know what common multiples are. So for that, let's take an example. Let's take the case of 4 and 3. So what are the multiples of 4? You have 4, you have 8, you have 12. That means 4 into 1 is 4, 4 into 2 is 8, 4 into 3 is 12, 4 into 4 is 16, then 20, 24, then 28, 32, etc, etc, etc. So these are the multiples of 4. Okay, so what are the multiples of 3? Similarly, you can write multiples of 3 as 3, 6, 9, 12, then you have 15, 18, 21, 24, then 27, 30, 33, etc., etc. Okay, so among these multiples of 4 and 3, which are the common multiples? So here you can see 12 as a common multiple, right? In both cases 12 is coming, that means 12 is a common multiple of 4 and 3, and similarly 24 is a common multiple, right? So among this common multiple, which multiple is the smallest one? So here lowest common multiple is 12. That means LCM of 4 and 3, which is the lowest common multiple, it is 12. Okay, so this is how you need to find out the lowest common multiple. So another concept that you need to understand here is that the next common multiple, that means the lowest common multiple of 4 and 3 is 12. Next common multiple is 24, right? Which means LCM 12 into 2. That means LCM is 12. If you multiply 12 with 2, you will get the next common multiple. If you multiply LCM with 3, you will get the common multiple that comes after 24, that is 36. So if you take the case of 4 and 3, common multiples will be 12, 24, 36, 48, 60, etc., etc., and the lowest common multiple will be 12. So you need to understand the concept of both the lowest common multiple and the concept of common multiples as well, because in some questions it's not just about finding out the lowest common multiple, but you also need to find out different common multiples as well. So now let us study various methods to find out LCM. So we'll be studying two methods. First one is the ratio method, and second one is again the prime factorization method to find out the LCM. So ratio method we won't be using much. Anyway, you just understand this method. Okay, so let us take an example. We need to find out the LCM of 12 and 18. So first you need to find out the ratio of 12 and 18. So ratio of 12 and 18 is 12 is to 18. So if you divide this by 6 on both sides, you will get 2 is to 3. So the ratio of 12 and 18 is 2 is to 3. Okay, now you do the cross multiplication. That means either you can do 12 into 3 or you can do 18 into 2. Both will be same. 12 into 3 is 36. 18 into 2 is 36. That means LCM of 12 and 18 will be 36. So this is the ratio method. So ratio method you can use when you are given when you want to find out the LCM of two numbers. If more than two numbers are given, then you go for the prime factorization method. So now let's look into the second method, which is the prime factorization method, and this will be the most commonly used method to find out LCM. So let's take an example. We need to find out the LCM of 12, 18 and 24. So just do the prime factorization just like we did for the case of HCF. So here 2 is a common factor, 6, 9, 12. So among these 3 is a common factor. You will get 2, 3 and 4. And when you look into 2, 3 and 4, there are no common factors for 2, 3 and 4, right? So in case of HCF, we would have stopped our calculation here. But in case of LCM, you need to continue even though it doesn't have a common factor. Okay, so here if you divide by 2, here it will become 1. For 3, the 2 is not a factor, so you just write 3 here. And for 4, when divided by 2, you will get 2. So again 2, this will become 1, 3 and 1. Now you can do 3, so it will become 1, 1, 1. So for LCM, you need to do the prime factorization till all the numbers become 1. But for HCF, you need to stop where there are no common factor. Okay, so now the LCM is equal to, just multiply all these numbers, that is 2 into 3, 6 into 2, 12 into 2, 24 into 3, which will come 72. Okay, so LCM of 12, 18 and 24 is 72. Now let us see how we can find out the LCM and HCF of two fractions. So if you are asked to find out the LCM of A by B and C by D, and also if you are asked to find out the HCF of A by B and C by D. So this is LCM of A by B and C by D is equal to LCM of numerator, that is A comma C, divided by HCF of denominator, which is B comma D. Similarly, if you want to find out the HCF of two fractions, it is equal to HCF of numerator divided by LCM of denominator. Okay, just remember that if you want to find out the LCM of two fractions, then it will be LCM in the numerator. If you want to find out the HCF of two fractions, then it will be HCF in the numerator. Okay, just remember that. So let's take an example. If you want to just find out the LCM and HCF of two fractions, 1 by 8 and 3 by 6. So HCF is equal to HCF of, that in numerator HCF will come, right? So HCF of 1, 3 divided by LCM of 8, 6. So HCF of 1, 3 is 1, because common factors of 1 and 3, the only common factor is 1. So HCF will be 1. And LCM of 8, 6 is, if you find out using prime factorization, you will get 2, 4 and it will come 3, then again 2, 2 and 3. So again 2, 1, 3, then you can 3. So 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24. So LCM is 24. So this will come 1 by 24. Then LCM is equal to LCM of 1, 3 divided by HCF of 8, 6. So LCM, lowest common multiple of 1 and 3 will be 3. And highest common factor of 8 and 6 will be 2. So this is how you find out the HCF of and LCM of two fractions. So these are some things that you need to remember. So this first one is a very important equation, which is HCF into LCM will be equal to the product of that two numbers. For example, in the previous example, we found out the HCF and LCM of two fractions, 1 by 8 and 3 by 6. So their LCM came to be 3 by 2 and HCF was 1 by 24. So LCM into HCF is equal to 3 by 2 into 1 by 24. So you got it as 3 by 48. Okay, now if you multiply A into B, that means multiply these two numbers, that is 1 by 8 into 3 by 6, it will come 3 by 48. So HCF into LCM will be the product of that two numbers. So this is the first thing that you need to remember. Secondly, if HCF of two numbers is 1, that means they doesn't have a common factor between them. Only common factor between them is 1. For example, if you consider like 3 and 14, that means HCF of 3 and 14. Is there any common factor between 3 and 14? No, there is no common factor except 1. So HCF of 3 and 14 is 1. Right. So in that case, 3 and 14 we can call it as coprime numbers. Okay, just remember, coprime numbers are those numbers whose HCF is 1. Now the third thing is, if A and B are factors of C, then LCM of A, B, C is C itself. For example, if you take three numbers, let's say 3, 6 and 18, and we want to find out the LCM of these three numbers. So this is an easy trick. Okay, here 3 and 6 are factors of 18, right? So 3 is a factor of 18, 6 is a factor of 18. So in this case, their LCM will be 18, the largest number. Okay, if two numbers are factors of the third number, then that third number will be the LCM. Similarly, if you see this fourth one, if A is a factor of B and C, then HCF will be A. For example, let us take the same example. Let's say we want to find out the HCF of 3, 6 and 18. Here 3 is a factor of 6, right? And also 3 is a factor of 18. So in this case, HCF will be the smallest number, 3 itself. So let's solve some questions now. What is the smallest number greater than 1000 that when divided by any one of the numbers 6, 9, 12, 15 and 18 leaves a remainder 3? So this is a UPSC 2022 question. Here you need to find out the number which is greater than 1000, and it is when it is divided by any of the numbers given here should give you a remainder 3. So if now that number when divided by these numbers will give a remainder 3. So if you subtract 3 from that number, then that number will be divisible by the given numbers here. So first here you need to find out the LCM. That means LCM of 6, 9, 12, 15 and 18. So if you divide by 3, you will get 2, 3, 4, 5 and 6. Again I am taking 3, it will become 2, 2, 1, 4, 5 and 2. Then if you divide by 2, it will become 1, 1, 2, 5, then 1, then 2, it will become 1, 1, 1, 5, 1, then 5, it will become all 1. So here LCM is equal to 3 into 3, 9, 9 into 2 is 18, 18 into 2 is 36, then 36 into 5 is 180. So 180 is the LCM of all these given numbers. So you need to find out a number which is greater than 1000, which is a multiple of 6, 9, 12, 15 and 18. So when I told you the concept of LCM, I told you that in order to find out the common multiple between given set of numbers, first you need to find out the LCM, and then you need to multiply LCM with a number, right? So here 180 is a common multiple of all this number, which is the lowest common multiple. Next common multiple will be 180 into 2, that is 360. Next will be 180 into 3, which is 540. Next will be 180 into 4, 720. Then 180 into 5, 900. And 180 into 6, 1080. So 1080 is the smallest number greater than 1000, which when divided by 6, 9, 12, 15 and 18 leaves a remainder 0. Here 1080 is actually divisible. It's a common multiple, so it is divisible by the given numbers. So in order to get a remainder 3, you just need to add 3 to the 3 to 1080. So answer will be 1083. So now let us solve another question. A person has to completely put each of the 3 liquids, that is 403 liters of petrol, 465 liters of diesel and 496 liters of engine oil in bottles of equal size without mixing any of the above 3 types of liquid such that each bottle is completely filled. What is the maximum possible number of bottles required? So here the question is like, you have 403 liters of petrol, you have 465 liters of diesel, then you have 496 liters of engine oil. So you need to fill this into bottles of same capacity such that it will be completely filled and there is no mixing, right? So here I will just explain to you with a smaller example. So let's say you have 20 liters of petrol, 30 liters of diesel and 40 liters of engine oil. In that case, what should I do? I should take containers of 10 liter size. Okay, let's say assume that our containers are 10 liter size. Then you need 2 bottles to fill petrol because there are total 20 liters of petrol. If you take 2 bottles of 10 liter capacity, you can completely fill the petrol. Similarly, if you take 3 bottles for diesel, then you can fill 30 liters of diesel, right? So if you take these 3 containers are 10 liter size, then if you take 3 bottles, it will be total 30 liters. So you can fill 30 liters of diesel in it. Similarly, if you take 4 bottles of 10 liter capacity, you can fill engine oil in it. So here total bottles required is 2 plus 3 plus 3, which is 8. So this is the question. So I have actually given you a simpler example to understand how you need to do it. So here actually the capacity 10 liter that we assumed for our bottle is the highest common factor of 20, 30 and 40. So if you take the highest common factor of 403, 465 and 496, you will get the capacity of the bottle. So let's find out the highest common factor of 403, 465 and 496. Here the thing is, if you are going to do this in prime factorization method, it's very difficult because these are bigger numbers. So it will be difficult for you to find out which prime factor is common, because here actually 3 is not common, 2 is not common. You need to find out which is common first. So it's actually a difficult process. So in this kind of questions, you can use the repetitive subtraction method. So let's take the repetitive subtraction method. So we need to find out the difference between 2 pairs, right? So 465 minus 403 is 62. So that is HCF of 62, comma 496 minus 465 is 31. 496 minus 403 is 93. Actually, you can conclude here because 31 is a factor of both 62 and 93. 31 into 2 is 62, 31 into 3 is 93. Now, I already told you that if a number is a factor of the other two numbers, then HCF will be that number itself. So here HCF is 31 itself. See, using repetitive subtraction method and using our trick, you found out the HCF in just 1 or 2 seconds, right? So that's the importance of repetitive subtraction method in this question. If you are doing by prime factorization, it will take a huge amount of time in order to find out the HCF in this case. So this 31 will be the capacity of the bottle. So how many bottles are needed to actually fill petrol? So there are 403 liters of petrol. So how many bottles are needed? It will be 403 divided by 31. So 1, 31, 93 is 3. So 13 bottles are required. Then for 465 liters of diesel, how many are required? 465. Then 1 is 31. You will get 5, 15, 155. 31 into 5 is 155. So 15 bottles are required. And for 496 liters of engine oil, you need 16 bottles. So total bottles required is 13 plus 15, which is 28. 28 plus 16 is 44 bottles are needed. So answer is D, 44. Otherwise, you can just add all these liters. Okay, 403 plus 465 plus 496. You will get 8, 14, 7, 9, 16, then 1364. You can just divide 1364 divided by this capacity, that is 13. 31. So you will get 4 into 31 is 124. Then 124. You will get 44 itself. So now let's look into one more question. So the question is, find the greatest number which divides 194, 258 and 386 and leaves a remainder 2 in each case. That means if that number, there is a number, if that number is number divides 194, you will get a remainder 2. If that number divides 258, then you will get a remainder 2. If that number divides 386, again you will get a remainder 2. That means 192, 256 and 384. How I got these three numbers? Just subtract 2, remainder 2 from each of this number. This will be exactly divisible by that number, right? So just what you need to do, you just need to find out the highest common factor of these three numbers, 192, 256 and 384. So since these are bigger numbers, we can use repetitive subtraction. So this is HCF of 256 minus 192 is 64, right? Then 384 minus 256 is 84 plus 44, right? So 88, 128. Now 384 minus 192 will come 192 itself. So here again we can do repetitive subtraction. So 128 minus 64 is 64. 192 minus 128 is again 64. 192 minus 64 is 128. So here 64 is the factor of 128. So HCF will be 64. So 64 is the correct answer. So thank you all for listening to this video. I hope this has been a good information to you. So if you like the video, please do subscribe, share and support. And if you want to join our Telegram channel, you can join the Telegram channel using the link that I'll be providing in the description as well. So thank you once again.